Hey students, welcome to lesson 8.3. We are going to get rocking right into it. For the most part, we are going to continue with this idea of circles, and instead of just merely looking at the perimeter or the outside, we are actually going to go ahead and start looking at the area. So if you felt pretty comfortable with 8.1 and 8.2, this should not be too bad. Okay, it does take a little bit of a dive in 8.4 as in difficulty, but for the most part, this is going to be pretty smooth. And let me rehash, don't forget, you can access all of these notes that I'm doing in this video in the online notes. If you prefer just to kind of walk through the notes yourself without listening to me, I know I get pretty dry and I definitely talk a lot, but if you can self-script yourself, look at the example set that I have in the online notes. All right, with that being said, 8.3 lesson set, here we go. Let's start with our key ideas as always. The key ideas in this case is just one thing. Again, we are going to deal with circles, but in this case, okay, I'm going to rehash the diagram, and I'm going to just focus on the radius in this time, okay? Because we're going to go ahead and solve for the area of a circle, and the area formula, which you have to memorize, okay, is pi times r squared. Okay, so many of you may remember this from past, but pi r squared, as it's quickly said, it can find us the area of any standard circle. Now, in this formula, we need the radius every time. Okay, so we are not going to use anything else other than the radius. If you feel like you're a glutton for punishment, as in you want to do something really challenging, you can use this formula, a equals pi times d over 2 squared, if you are given the diameter. Personally, I would not recommend that. Just go ahead and use the first one. Many of you already know how to find radius by just splitting the diameter in half. So that's going to be what I'm going to work with. Okay, so let's go to the first example set. It is very straightforward. Okay, so for both of these, you're going to notice I'm going to set them up in tandem because the actual calculations isn't bad. Just be careful with what you're given and be careful to use pi appropriately. In these examples, it does ask us to use 22 over 7 for pi. I'm just going to go ahead and erase those directions. Okay, use 3.14 or the pi key. Okay, use 3.14 or the pi key. Personally, using the pi key is appropriate, and round to the nearest hundredths in most cases. So round nearest hundredths. So we're going to keep that as a general directions that you should know all the time. Okay? In Big Ideas Math, sometimes it does ask you to round to the whole number or the tenth. Just make sure you read those directions carefully, but when I'm going over many of these problems, hundredths is perfectly fine. So let's set this one up. It definitely gives me the radius. So a equals pi r squared is, I like to start with the formula first, then plug in everything afterwards. Pi times 7 squared. Notice I'm keeping the triangle format, keep everything lined up. Don't get lazy with your scratch work and your organized triangle format work because we want to keep it fairly scripted. Finishing it off, it becomes a equals, I'm going to do the next step in my head. 7 squared is 7 times 7, that's 49. It's 49 pi. Okay, now at this point, handy dandy calculator. Okay, so I'm going to go 49 using the pi key. It comes out to be 153.938 blah blah blah. So it is going to be approximately 153.94 because I rounded up because it was 938. And now the units are going to be a little different. It's going to be centimeters squared. Okay, we use squared units, as many of you should hopefully remember from last year. We use squared units for any type of area measurement because we're talking about a two-dimensional measurement. Okay, area is two-dimensional, so we use the centimeters squared. If you don't remember that, just think of it with the squared comes from the r squared right there. Okay, translates. But that's pretty much it. There's not much more to this, but for the most part, just be careful what you're given. Like at B, a equals pi r squared. And I noticed right away that 26 is the diameter. Well, let's just go ahead and use the radius. It's half that. So a equals pi times 13 squared. So there's nothing different about what we're going to do with diameter. We just got to go ahead and split it in half. So finishing this off, A equals, and let's go ahead and punch all that out. 13 squared is 169 pi. And finishing that, it comes out to be a fairly decent number of 530.929. So 530.93 I'm going to round it to, and this time it's in inches. Okay. After this, okay, 8.3 is going to be basically practicing just these types of circles. Okay, they don't get any more challenging than this, other than what the circle looks like and the numbers that you get. Okay, be comfortable also that because we're talking about area and we're finding the inside, okay, the numbers do get a little bit larger because of that squared unit. So if the diameter or the radius is pretty big, be comfortable knowing that an answer like 500 is, all right, is appropriate. It works. All right, with that being said, pause this video if you need to and review this. I'm going to move on to example set 2. Boom, here we go. All right, we can't forget about our lovely semicircle. So semicircle, as you already know from 8.1 and 8.2, is just half of it. So it makes sense that when we are finding the area of a semicircle, we're going to use pi r squared, but we're going to divide by 2, okay, because it's just half of it. You can use this formula as I've written it here, or just divide by 2 at the very end. Personally, I like to go ahead and write it out the whole time and make sure that I don't lose track of it. Okay, and for those that are hearing, that's my phone going off. I should have probably put it on silent. Okay, I'd be very surprised if anyone knew what that sound actually is. It's Navi from Zelda. All right, so anyway, let's continue here. A equals pi times radius squared. This looks like the radius is going to be half of this diameter of 30, so it's 15 squared divided by 2. Now, if you use the formula that I've given you for the semicircle, okay, you always do the top first. Order of operations, we're going to do the top first and do the divide by 2 last. Save that for the end. So at the top, it's 15 squared, which is 225 pi over 2. Okay, so as I'm continuing here, the next step, I would just use a calculator entirely. I'm going to go 225 times the pi key, then divide by 2, and it comes out to be approximately 353.429, which I will round to 0.43, and it is in feet squared. So nothing different about what we do with the area formula other than dividing by 2 for a semicircle. Of course, in your work, there may be portions where you might have to divide by 4, divide by 6. It depends on how the circle is split. But the core thing to remember is that you now have a new formula called A equals pi r squared. All right, with that being said, okay, let me zoom out, just take a look. This is what we looked at here today. There's nothing more than this so far. So I'm going to ask you to pause this video if needed, double check your notes, and then I'm going to go and flash the OYO portion of this video. Okay? All right. So this is the on your own section. So there is 6 problems that I would like you to try. Okay, so at this point, I'm going to just pause the video for about 5 seconds. You can pause it yourself, but I'm just going to give you a little bit of a pause. And then when in about 5-6 seconds, it should pop up with the answers magically, and I'll go over anything specific that needs to be done. So go ahead and work on these 6 problems on your own. All right, students, what you should see is all the answer key for all 6 problems. At the very top, 3, 4, and 5 are just standard area of a full circle. Notice that I did round to the nearest hundredths. Just kind of keep that in mind as we're consistently going through. In the first problem, number 3, I did write the formula, but everything afterwards, I just consistently went straight to the substitution. If you're comfortable with that, no worries. Just memorize that formula. And then for the semicircles, 4, 5, and 6, don't forget to divide by 2. The only awkward one will maybe possibly be number 5 because you have a decimal, and it doesn't really change the work though, so just be aware that ugly numbers do exist. Okay. All right, so take a moment to check over your work and look at the method. Okay, and then in a moment I will go ahead and wrap this up. All right, so that concludes this video for 8.3 Lesson 1. Feel free to review at your own leisure. And after this, on Tuesday's work, I am going to go ahead and roll it out in Big Ideas Math Online for you to practice. Okay? If you have any questions, like usual, feel free to reach out to me through Remind and email. Thanks. Have a good day, kids.